All right, folks, welcome back to the second practice problem in the 6.1 area between curves practice. So let's take a look at this question. It says find the area of the region bounded between the graphs of f of x equals 9 minus x over 2 squared and g of x equals 6 minus x. So again, it's good practice to know what these curves look like. So when I look at the equations, I can tell that this is a line, and I bet you can too. And I know that this one is going to be a parabola. So that's also good to know, okay? Now, based off of that, I know that the f of x curve is the one in the red, okay? So I'm going to color code that to match the Desmos graph. And I know that the g of x is the one in the blue, or the line. Now this is a little different from the previous problem in the sense that they don't tell us where to start and stop. They just say the area of the region bounded between the graphs. So we can take the same formula that we started with in the other one, which is area equals the integral from a to b of the, not f of x, the top curve minus the bottom curve. And when we think about how that's going to play out in our equation, we know that our top curve is the red one. So I'm going to go ahead and put that in there, 9 minus x over 2 squared, okay, minus the one in the blue, which is 6 minus x. And then I'm going to seal that off with a dx. Now, what I haven't found, though, is where I start and where I stop. So maybe what we should do first is sort of identify the region we're trying to find the area of. So the region I'm trying to find the area of is the one between the curves, or bounded between the curves. And so that's going to be this region right here. All right, so that is the area that we're trying to find. So where does this region start and where does it stop? Well, it looks like it starts here at -2. So I can put -2 down here. And it looks like it stops here, or this was at 6 before I colored over it, okay? So that's how we can find our bounds from a graph. And so let's go ahead and work through this problem, and then at the end I'm going to show you a different way to find your bounds, how to find them algebraically, and that's going to be something I look for on a test too, is can you find it algebraically as well as graphically. So let's simplify our area equation here. We've got area equals the integral from -2 to 6 of 9 minus, I'm going to distribute that squared, so x squared over 4, and then minus 6, and then don't forget to distribute that minus sign, plus x dx. All right, so that minus goes to both terms there. And like I did in number 1, I'm going to go ahead and combine some like terms before I find the integral. So from -2 to 6 of 9 minus 6 is going to be 3. And then I have plus x and then minus x squared over 4 dx. And now I'm all set to take the integral. So I'm going to get 3x plus 1/2 x squared minus 1/4 times, let's see what happens to x squared. Well, x squared goes up to x cubed, and then the reciprocal of 3 is 1/3. And I'm going to draw a bar and put 6 and -2. All right, let's simplify this before we plug in our numbers. 3x plus 1/2 x squared minus 1/12 x cubed from -2 to 6. All right, let's plug in our numbers. We're going to plug in the top bound first, right? We're going to plug in the 6 first, and then we're going to plug in the negative 2. So 3 times 6 plus 1/2 times 6 squared minus 1/12 times 6 cubed, all right? And then I'm going to subtract 3 times negative 2 plus 1/2 times negative 2 squared minus 1/12 times negative 2 to the 3rd. Okay, well, let's bring this over here so we have enough room to go horizontally. And so when I clean up the first bracket, I'm going to get 3 times 6, which is 18, plus, I'm going to keep this over 2, so 36 over 2. Now I know that reduces, but I want to leave it over 2 for just a little bit longer. Minus 6 cubed is going to be 216 over 12. So all of this is from here, okay? I've just multiplied out some of the powers. Minus 3 times negative 2 is going to be negative 6, plus this is going to be 4 over 2, and then minus a negative 8 over 12. Okay. Now, I took the time to write this out so that I could make sure I distributed my negative sign correctly. And this is going to give me 18 plus 6. So I'm kind of already grouping them in like terms, okay? Plus 32 over 2 minus 4 over 2. And then minus 216 over 12 minus 8 over 12. Now, I'm going to combine what I have. So 18 plus 6 is going to give me 24, plus 28 over 2 minus 216 minus 8, or negative 216 minus 8 rather, is going to be negative 224 over 12. And now, to combine everything, I am going to see what I can reduce first, okay? So I can see that 28 and 2 are going to reduce to 14. So I have a whole number there. Now, does 224 divide by 12? And the answer is no, but they both divide by 4. So I get a 3 on the bottom, and I get a 56 on the top. And so now I get 24 plus 14, which is going to give me 38, minus 56 over 3. And I'm going to make 38 into a fraction over 3. So I get 114 over 3 minus 56 over 3. And 114 minus 56 is going to give me 58 over 3. And that is not divisible by 3, so we're going to leave it like 58 over 3. Okay, so here is the whole question. Whoa, here's the whole question on one page. All right, and as promised, I saved some space for us to go back and figure out how to find our bounds in case we didn't have a graph, okay? So in that empty space beneath the graph, I'm going to show you how to find those bounds algebraically. How did we get that negative 2, and how do we get that 6? Okay, so let's carve out some space for ourselves and do the work of finding the bound. So, to find the bounds. To find the bounds, it's actually quite simple. We're just going to take the two curves and we're going to set them equal to each other. So we've got f of x is going to equal g of x. And that's going to give us 9 minus x squared over 4 equals 6 minus x. Now, I'm going to go ahead and get rid of that 4 on the bottom by multiplying everything by 4. So 9 times 4 is 36, minus x squared equals 24 minus 4x. Now I see that quadratic, so I'm going to move everything to one side and set it equal to 0. So I'm going to get 0 equals x squared minus 4x. And then I've got to do 24 minus 36, which is going to give me negative 12. And now that we have our quadratic, we can factor. So x minus 6 times x plus 2. And when we set those individual parts equal to 0, we will get x equals negative 2, which is our a value or our bottom bound. And we get x equals 6, which is our b value or our green bound, our top bound. Okay, so this is our top bound, and this is our bottom bound. All right, so there we have example number 2, all on one page. All on one page. There are 2 ways to find the bounds. You can find it on the graph, but you also need to know how to find it on with algebra, okay? And we want to make sure that we know how to simplify and plug in our numbers accurately. And I'm intentionally doing this all with fractions because that's how most of our answers should be for things like WebAssign, okay? So this is a classic kind of problem where we're looking at, really we could do this without technology, but because we're doing this remote, I want us to make sure we have a picture there so that we can see what it is that we're finding. All right, so that's it for number 2. We got 6 more examples, so come on back and take a look at those other videos. All right, see you later.